Okay, everyone, we're going over chapter 3, homework number 10, number 114. David wants to solve the equation that you see right there. Big numbers. What easier equation could he solve instead that would give him the same solution? In other words, what equivalent equation has easier numbers to work with? So you see how all these are in the thousands? You can actually divide each of them by 1,000, which means that you just basically erase all the zeros, or 3 zeros at least. So now you have 4 divided by 1, x, 8 divided by 1, and 16 divided by 10. So that one's a little, 16 divided by 1. So what other equation can you write down? You can write down 4x minus 8 equals 16. And that's an equivalent equation that you can write and that you can use instead of the one given. Justify how your equation in part A is equivalent to. So basically by doing this, you have to find out the answer is the same for both one. Okay, so we'll start with the one in part A first. Okay, so that's 4,000x minus 8,000 equals 16,000. Okay, so first you got to solve this. Add 8,000. These cancel out, and you get 4,000. X equals 16,000 plus 8,000 makes 24,000. Okay, then you gotta divide it by 4,000. Okay, when you do that, these cancel, and you get x equals, and 24,000 divided by 4,000. If you do that in your calculator, you will get 6. Okay, second part. 4x minus 8 equals 16. If we do this, we will add 8. And you see some similarities just without all the zeros. You get 4x equals 16 plus 8 is 24. Divided by 4. These will cancel. You get x equals 6. So yes, both of these are the same equivalent equations. C, David's last equation, the fraction ones right there, is that write and solve an equivalent equation with easier numbers that would give him the same answer. Okay, so let me write that down. Let me rewrite that down. Okay, so that is x over 100 plus 3 over 100 equals 8 over 100. Right? And what we can do is multiply everything, both sides, by 100. What that does is 100 times x over 100, and those 100s are going to cancel. So you would just get x. And then when you go 100 times 3 over 100, and those 100s are going to cancel as well. And you get plus 3. And then these right here, these hundreds are going to cancel, and you just get x, or excuse me, 8. From here, all you got to do is subtract 3, and you get a final answer of 8 minus 3, or 5. So answer is x equals 5. Okay, so first you have this equation here. That's the easier one. Well, excuse me, that's the easier one. That's your original equation. This one right here, This equation here is your easier one. This is your easier equivalent equation with easier numbers. And then that x equals 5, that is your final answer. Okay, backside. Multiply each of the following expressions, show all of your work. Okay, meaning that if you're going to use area model, show the area model. Don't just do it in your head. Don't partially do it. Do the whole thing. So this is going to be x plus 3 and 4x plus 5. You're going to go ahead and do the multiplication for that. So you're going to go ahead and take x and multiply it by 4x, which would be 4x squared. And for this one right here, you're going to take x and multiply by 5, and you're going to get 5x. This one out on the bottom left, you're going to multiply it, and you're going to get 12x. This one on the bottom right, you're going to get 15. Excuse me. Final answer, you're going to put them all together, or you can write it over here. All right, so this is the product because there's two things being multiplied together. Two quantities being multiplied together. And this over on this side is the sum. The sum is 4x squared from here. And the sum is also 5x plus 12x, whatever that makes. So 5x plus 12x makes 17x. And then the rest of it, the sum is adding the rest of it up, plus 15. Ugh. Sorry. Okay. Part B. Do another area model. This is 3y minus 8 and negative x plus y. And go ahead and multiply them out. Negative x right there times 3y makes a total of negative 3xy. You can also put yx, but it is customary to put the x in front of the y. Next up, we have this other square, and we want to use the negative x and the negative 8. So negative x times negative 8 makes positive 8x. Okay. Okay. This square down here, bottom left, we need the y and we need this length. And this right here is going to be the same length as that, which is 3y. So it's 3y times y makes 3y squared. And then we need this last one on the bottom right. And we need this length and this length. Length times the width, right? Or we can say the bottom. Doesn't matter how you do it. This bottom piece is the same as that middle piece, which is the same as the top piece. So that's negative 8. This piece, this piece right here is the same as this piece, which is positive y. So with negative 8 times positive y, and you get negative 8y. Okay. So same thing as the last one. I'm going to go ahead and total up what's the same. In this case, they're all going to be individualized. So you got 3y squared. Nothing else has a y squared in there. So your answer is going to be 3y squared. Then you also have, let's go with negative 8y. Nothing else has just a number and a y, so that's all you get. So you're going to put down minus 8y. And then you also have negative 3xy, and nothing else that you have has an x and a y with it. So you're going to write down negative 3xy. And then finally, you have just a plain x terms for 8x. And there's nothing else that has the same term. So you're just going to go ahead and just put that down, plus 8x. That's your answer for part B. for part, or excuse me, that was it. Okay, the last one, copy the diagram below on graph paper, then find the result when each indicated transformation is performed. Okay, this is going to be reflection, so I'm going to start off with drawing points at each vertices or at each corner of my shape, and I'm just going to count how, or mirror how many units there are from the line of reflection. Okay, so there's a line reflection right there, which is line L, and I'm just going to go ahead and kind of trace them. Okay, so this is 1 unit, then I'm going to go 1 unit, and I'm going to go ahead and put a dot here, put purple. Okay, if up here is 1, 2, 3, 4, 5 units, then I'm going to count 1, 2, 3, 4, 5, and I'm going to go ahead and put my point there. Oops. Okay, start over. 1 unit, so I'm going to go 1 unit down and put my point there. Okay, this is 1, 2 units, so I'm going to go 1, 2 units down and put a point there. This is 1 unit up, so I'm going to go 1 unit down and I'm going to put a point there. And then finally, I've got 1, 2, 3, 4 units down, so I'm going to go 1, 2, 3, 4, and I put a point there. Then I'm just going to go ahead and draw in my shape. There, 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 there. Oh, sorry, copied it wrong. Let's see. There, goes up here, down here. There you go. That's my reflection. It needs the same strategy, except we're doing rotation. And we're going to use something called the hook, right? And we're going to do 90 degrees counterclockwise. So I'm going to go ahead and put down some points. For example, that point, that point, that point, and that point. So I'm going to do a hook. Draw up to right 3. And if I do counterclockwise, I'm going to put this in orange so you can tell it's related. Counterclockwise, that means against the clock. That means that instead of up 2, I'm going to be going to the right. Sorry, left 2. And instead of right 3, I'm going to be going down 3. So that top point is going to end up right here. Yeah. Okay, same thing. For this point right here, I'm going to go, and you can go in any order you want. I'm going to go right 2, down 1. So if I rotate this counterclockwise, then it's going to be, instead of to the right, it's going to go down 2. And then instead of down 2, it's going to be to the right. Now you can just see that it's just like this thing right here. It's just kind of hooking over. It just turns 90 degrees that way. See that? And it's going to be on the P. So that's all that happened. Okay. And that's going to be my point, which I'll put in purple. Okay. And you can start connecting the dots if you want. If you don't want to get confused, because we just connected, we just did these two right here, right? So that's, if it's rotated 90 degrees counterclockwise, that's what it's going to look like. Okay. This next one, it looks like from here, I'm going to go 1, 2, 3, 4, 5. So when I rotate it counterclockwise, it's going to go down. So it's going to be, and I'm going to put this in orange. 1, 2, 3, 4, 5. And that's going to be my next point. And that's only from here to here. Oops. Clean this up a little bit. The palm of my hand keeps rubbing against it. And then last one, we have from here, I'm going to go and say 1, 2, 3, 4 to the right and left, and then 1, 2, 3, 4 down. And if I do a hook for that, so instead of 4 right, it's going to be 4 down, and instead of 4 down, it's going to be 4 to the right. So 4 left will end up being 4 down. 1, 2, 3, 4. Now 4 down will be 4 to the right. 1, 2, 3, 4. That's where I'm going to end up at. This one's fairly tough. Right, so I'm going to connect your dot, and that's the image of B. Rotate this, letter C, about point Q. Yeah, I'm going to start off with my corners, my vertices. And clockwise, or C right here, what says C 180, that just means clockwise 180. Oh, actually, no. I was assuming that. It's image C. But the cool thing about 180 is it doesn't matter if it's clockwise or counterclockwise. It's the same exact direction. I mean, you end up in the same exact place. So, for example, this right here, instead of up 3 units, it's going to be going down 3 units. 1, 2, 3. And that's where we will end up at. Okay. This point right here. So instead of 1, 2, 3 to the right, it's going to be 3 to the left. 1, 2, 3. All right. So far I've gotten from there to there, which in my case is there to there. Okay. Okay, this point down on the far bottom, okay, it's going to be, and I'm going to go ahead and do down 2 and then right 3 times. So 180 degrees would mean that this right here, let's see if it sticks together. Yep. 180 degrees would be, you see my handle where it started at the top, my little green handle. So rotate 180 degrees would mean that it would be at the bottom now. So it would look like that. Okay. But then it would be like this. Okay. So instead of down 2, right 3, it would be up 2, left 3. And that would be where my purple point is. And so far, we've done that. And so far for our image, it's going to be like that. Okay. Okay, let's go with this point right here. This point looks like, you know what? It looks like it's going to be up 2 and then right 1, 2, 3, 4, 5, 6, 7 to get all the way over there. So instead of up to right 7, we're going to go down 2. So 1, 2, and then right and the left 7. 1, 2, 3, 4, 5, 6, 7, all the way at the end. I'll get rid of all that later. And what we've just done was we've connected this blue dot to that blue dot. So which means that on our purple, we will connect that purple dot to that purple dot. You can see that it looks, now it's starting to take shape, and it definitely looks like it's upside down. Okay, it's just the same thing, just flipped around. Okay, almost done. Just bear with me, or fast forward if you need it. This point right here, so we're going to be going 1, 2, 3, 4, 5 to the left. Sorry, 5 to the right, and 1, 2 up. 5 to the right, 2 up. So exactly the opposite. 5 to the left, 1, 2, 3, 4, 5, and then 2 down. And we're right there. That's where I'll put my purple point. And what we've done was we've connected there to there, which means that we will be doing here to here. Okay, this point on top, the last point. We can go left or right or up and down, doesn't matter. I'm going to go up. So 1, 2, 3, 4 up, and 1, 2, 3 to the right. So exactly opposite is 4 down, 1, 2, 3, 4, and then 3 to the left. 1, 2, 3. That's where we end up at. Oops, I need purple for that. Okay, so remove that and remove that. Just bouncing around. And what we've done was we connected there to there. And for us, it'll be here to here. And then we also completed this. And so we will also complete that. Okay, that's going to be 180 degrees. Takes a little bit of time. Okay, good math takes time. I'm not expecting to do this in 10 seconds or 30 seconds. Okay, so this is the last one. We're going to reflect this across that line M. And again, I'm going to draw my points at the vertices just to kind of help me along. You can label names and all that stuff if you want. Okay, I'm going to go ahead and go with a diagonal because it looks like I can hit it at a diagonal. So I'm going to say, diagonally like that. So I'm going to go diagonally like that and put a purple point right there. Okay. Again, I'm going to go diagonally 1, 2. So I'm going to go diagonally 1, 2. I'm going to put a purple point right there. Okay. So far, we've gotten there to there. So for us, we will have from here to here. Okay. Diagonally, this one right here. Looks like it's 1, 2, 3, 4 and a half. So I'm going to go a half and then 1, 2, 3, 4. And that's where my image is going to be at. Okay, so what we've done was we've connected this side to this side. So we're going to have to connect this side to that side. And last one, we've got 1, 2, 3 whole diagonals. So we're going to go 1, 2, 3 whole diagonals as well. And that's where our final image point is going to be at. And we shall connect the last two right there, which means we're going to connect the last two right there. Then, well, these are the last two, which means that this is the last two. Okay. That is a wrap. If you need help or if you want to go through any of these again, just rewind it. You know what I mean. Okay.